Hello, welcome to the fourth lecture on representing data. Our learning outcomes are to calculate frequency density and to draw and interpret histograms. So what does a histogram look like? Here is a histogram. But what are the features of a histogram? Well, it's a diagram. So a histogram gives a picture of how the data is distributed. The variable is continuous and is displayed on the horizontal axes, in this case length. The data is from a grouped frequency distribution, so the class boundaries are used as markers on the horizontal axes. We can see here, in this case, we have 0.5 values as our class boundaries, and there are no gaps between the bars of the histogram. The area of each bar is proportional to the frequency for that class. Frequency density is displayed on the vertical axes. But what is frequency density? Well, to answer this, let's consider. The bar is a rectangle, so we can see that the area of the bar is equal to the class width multiplied by the frequency density. That's the width of a bar multiplied by the height of a bar to give the area of the bar. But we've said that the area of the bar is proportional to the frequency. What does this mean? This means that the area of the bar equals a constant times the frequency. We have used the constant k. Now, when we draw a histogram from grouped frequency table, it's most convenient to choose the proportional relationship to be a one-to-one relationship. In other words, let k equal 1. And this will give us the area of the bar does in fact equal the frequency. When we have to calculate the frequency density, remember that the area of the bar is equal to the class width times the frequency density. But also, the area of the bar equals the frequency when we assume that k is 1. Put these two together and we have that the frequency equals the class width times the frequency density. Now it's the frequency density we're trying to calculate from our table of values. So rearranging, we have the frequency density equals the frequency divided by the class width. Let's look at an example of drawing a histogram. The heights of a year group of children were measured. The data is summarised in the following group frequency table. Draw a histogram for this data. Now, to draw a histogram, we need the frequency density. It's the vertical axis. But to calculate the frequency density, we need the class widths. And to find the class widths, we need the class boundaries. And previously, we said to decide the class boundaries, we need to know whether there are gaps between the classes, not between the bars, between the classes. So we're going to add some columns to our table. Let's add the lower boundary and the upper boundary. Now, in this case, our data does have gaps. We go from 144 to 145. So if we have gaps, that means we use the middle value between the gaps. So here are the lower boundaries and the upper boundaries. So we need to calculate class width, but remember class width was upper boundary minus lower boundary, and doing the sums, we find the class width. The first one, 144 minus 144.5, that's better, minus 134.5 equals 10. And we repeat this calculation for the rest of the classes. And we can see that we actually have unequal class widths, 10, 5, 5, 5 and 15. Now we need to find the frequency density. Now we're drawing a histogram, so we're going to use our formula, frequency density equals frequency divided by class width. And again, a very simple calculation. We have in the first class, frequency of 40 divided by class width of 10 gives frequency density of 4. And repeating this for the other classes, we find we have frequency density 8, 15, 13 and 4. Now remember, on our histogram, frequency density is our vertical axis, and the horizontal axes we use the lower boundaries and the upper boundaries. So let's put that together, and here we have our frequency. And you can see the lower and upper boundaries along the horizontal axes and the frequency density along the vertical axes. Now let's look at an example of reading a histogram. A farmer weighed a random sample of cows. The weights were summarised in a group frequency table and were represented by the opposite histogram. We're given some extra information. We're told that the class 28 to 32, which is here, has a frequency of 32 and has dimensions of 2 centimetres by 2 centimetres. Okay, so we're saying that we have a frequency in here of 32 and the dimensions are 2 by 2. Okay, this is important because it's telling us how to delineate our histogram. So, what do we want to know about this histogram? Give a reason to justify the use of a histogram to represent the data. What is the underlying feature associated with each of the bars in a histogram? Show that on this histogram, each cow was represented by 0.125 centimetres squared. How many cows did the farmer weigh altogether? And estimate the number of cows that weighed between 25 and 29 kilograms. So let's do the first two parts, A and B. Well, the reason to use a histogram is because weight is continuous data, and we use histograms for the continuous data. What is the underlying feature associated with each bar? Well, remember, the area of the bar is proportional to the frequency. So let's do part C. Show that on this histogram, each cow was represented by 0.125 centimetres squared. So we've just said that the class 28 to 32 had a frequency of 32 and had dimensions of 2 by 2, which means we have an area of 4. So if we consider the ratio of area to frequency, because area is proportional to frequency, in this case we had an area of 4 represented a frequency of 32. So rearranging to find out the area for one cow, we just do 4 divided by 32. And 4 divided by 32 is 0.125, hence one cow is represented by 0.125 centimetres squared. Let's move on to part D. But just a quick note to remember that in this case, we actually have K is equal to 0.125. One cow is represented by 0.125 on the area. It's not a one-to-one relationship. So part D. How many cows did the farmer weigh altogether? To answer this question, we need to find the total area on the histogram. And remember that the class 28 to 32 had an area of 2 by 2, which was 4. So that tells us that our total area is, we have 2 times 2 here, plus 1 times 4, plus 1 times 8, plus 2 times 2, plus 1 times 1. And add that up and we get a total area of 21. But we know from part C that an area of 0.125 centimetres squared represents 1 cow. So we can use this. That means an area of 21 centimetres squared represents a frequency of 21 divided by 0.125. And doing the sum, 21 divided by 0.125 is 168. Hence the farmer weighed 168 cows altogether. The last part is to estimate the number of cows that weighed between 25 and 29. Now this is grouped data, so we do not have the exact values. And that's why the best we can do is to find an estimate for this answer. Again, we're going to consider the area on the histogram covering the weights 25 to 29. And here they are, from 25 to 29. We need to know that area. Well, looking at it, that area is split into 3 bars. One here, and another one here. So we need to know the area of each bar. And remembering to use the same dimensions as before, then we can see the first area, this one. This is 0.5 times by 4. Then the second area, this one. This is 1 times 8. And finally, this last area here, this is 0.5 times 2. So add those all together and we have an area of 11. But we need to know the number of cows. So returning to our ratio from part C, 0.125 area represents 1 cow. We need to know 11, an area of 11. So an area of 11 is represents 11 divided by 0.125 cows. And doing the math, as they say, 11 divided by 0.125 is 88. Hence we estimate 88 cows weighed between 25 and 29 kilograms. So in summary, a histogram gives you a picture of how the data is distributed. Histograms are used to display continuous data collated into a grouped frequency distribution. That's data from a grouped frequency table. Since the data is continuous, there are no gaps between the bars. The variable is displayed on the horizontal axes and the frequency density is displayed on the vertical axes. The area of the bar is proportional to the frequency. Area equals k times the frequency. When drawing a histogram from a table, use a 1-to-1 proportional relationship. In other words, k equals 1, which leads to the formula frequency density equals frequency divided by class width. Now please try the question.